Hello everyone, this is Pooja Ramaswamy, and today I'm going to talk about fast entity linking in noisy text environment. Using data mining to map ambiguous terms to constituent entities. This presentation is based on a paper published in KDT 2018 called Pangloss Fast Entity Linking in Noisy Text Environments. So the problem is to map potentially ambiguous terms in text to their constituent entities in a knowledge base. Pangloss disambiguates name tags in real time as a user types the text. As a text is typed, the internal and external topics are automatically added as tags, each of which results to named entities in our system. As we can see, named entity disambiguation is a task of mapping ambiguous phrases and texts. As shown here, the word Python can mean three different things. It could mean high-level programming language Python, or it could mean Python belonging to snake family, or Python that can be a missile. These ambiguous phrases are called surface forms, and these are mapped to canonical entities in a knowledge base like Wikipedia. Entity linking takes into account the semantic context in which a phrase occurs to make a decision regarding each surface forms. Annotating text in this way is useful for organizing content, extracting structured data from documents, and in machine learning application like semantic search, knowledge graph construction, and question answering. This uses real-world datasets such as messaging, resumes, or short-form social media, non-grammatical, loosely structured texts. Datasets like Wikipedia provides an excellent starting point as a source of knowledge base entries. Common Crawl represents a sample of web crawl data containing raw web page data, metadata, and text extracts. Workplace Chat dataset, a manually annotated dataset of workplace communication. So why do we expect it to work? Pangloss, which is a production system for entity disambiguation on noisy text, combines a probabilistic linear time key phrase identification algorithm with a semantic similarity engine based on context dependent document embeddings to achieve better than state of art results, greater than 5% in F1 score. Pangloss leverages a local embedded database with a tiered caching architecture to house its statistics and metadata storage, a design decision that ensures data locality at interference time. This allows rapid disambiguation of streaming context and on-device entity disambiguation in low-memory environments like mobile phones. Real-time entity linking by Pangloss service proceeds in several stages. A passage of text submitted to the system is algorithmically tokenized to identify substrings or surface forms which may have corresponding entries in Wikipedia. For each surface form, Pangloss calls a RocksDB key value store to retrieve candidate entries based on associations between hyperlink anchor text and Wikipedia URLs in Wikipedia and Common Crawl's datasets. The passage surface form candidate entry undergoes several feature generation steps, which include representational embedding using 300-dimensional vectors stored in RocksDB. Candidate entries are scored using an XGBoost based learning to rank model during the disambiguation phase, with top ranked candidate passed to the model, which determines whether the system should abstain from forming the association. Finally, the collection of linked entities is returned to the caller. Pangloss exhibits best-of-class performance on all three datasets, showing a 8.6% improvement over the next best system for MSNBC, a 7.6% increase for Acquaint, and a 15.4% improvement on workplace conversations. I hope you liked the presentation. Thank you so much.